One of the biggest analytical mistakes I see in early discovery does not look like a mistake at the time. In fact, it often looks like good science. It feels rigorous, careful, and well-intentioned, which is exactly why it's so easy to miss. This single mistake, hiding in plain sight, can derail even the most promising programs. Teams believe they are being thorough. They think that generating more and more data will automatically reduce risk. They believe that if they apply incredible rigor early on, they'll prevent problems from ever showing up later. But in reality, this approach often creates confusion, delays progress, and introduces downstream issues that are incredibly difficult and expensive to unwind. So, what is this mistake? It's treating early discovery analytics as if it were late-stage development analytics. It's applying the same expectations, the same level of rigor, and the same interpretation standards far, far too early in the product lifecycle. In early discovery, the rules of the game are different, and pretending they aren't is a recipe for trouble. This usually shows up in very specific ways. You'll see teams validating their analytical methods to late-stage standards way too early. Long before the method and the manufacturing process are even stable, they'll overcharacterize every tiny impurity before the chemistry is even locked down. They get bogged down chasing every single peak, every minor shift, or every tiny signal of variability. And they fall into the trap of assuming that this very early data must eventually support their final regulatory arguments. Now, teams do this for completely understandable reasons. They want to reduce uncertainty and feel more in control. They want to look prepared and credible in front of leadership. And, of course, they want to avoid any nasty surprises later on in development. These motivations all make perfect sense, but the way they are executed often backfires, creating the very problems they were trying to prevent. Here's why it backfires. Early discovery data is, by its very nature, immature. The processes used to make the molecule are still changing. The formulations are constantly evolving, and the analytical methods themselves are not yet optimized or fully stable. When you treat this kind of dynamic, preliminary data as if it's the final, definitive truth, you create far more problems than you solve. Some noises may be created, not clarity, and this leads to a dangerous sense of false confidence. When this immature data is treated as definitive, teams lock in assumptions that feel like they're supported by solid evidence. But these assumptions often don't survive the realities of scale-up, process changes, or formulation refinements that inevitably happen later on. You build your foundation on sand, thinking it's solid rock. Then, the real downstream impact hits. Later in development, when the manufacturing process inevitably changes or the analytical method evolves, teams suddenly face huge comparability questions. They have conflicting datasets that don't tell a coherent story. They struggle to provide clear rationales for their decisions because the early data doesn't align with the new reality. This creates credibility gaps that raise tough questions internally and eventually with regulators. We need to completely reframe the purpose of discovery analytics. Its job is not to close the story and give you all the final answers. It is not there to define the final control strategies for manufacturing. The true purpose of early analytics is to inform direction, to highlight emerging trends, and to guide the scientific thinking of the team as they navigate the complexities of early development. This requires a different mindset and asking better questions. Instead of asking for certainty, the right questions in discovery are things like, what do we think really matters right now, based on what we know today? What potential risks are just beginning to emerge on the horizon? And what signals should we continue to watch closely as both the molecule and the process continue to evolve? It's crucial to understand the difference between data quantity and data meaning. Simply generating more data does not automatically lead to better decisions. What really matters is whether the data you generate is fit for its intended purpose at that specific moment in time. High-quality data that lacks the proper context can be just as misleading, if not more so, than low-quality data. This brings us to the idea of phase-appropriate rigor. Early discovery analytics should absolutely be scientifically sound and internally consistent, but they must also be flexible enough to evolve. Rigor is still incredibly important, but it has to match the maturity of the molecule and the program. Applying late-stage rigor to an early-stage program is like asking a toddler to run a marathon. It's not just ineffective. It's counterproductive. This is where leadership becomes critical. A key responsibility of analytical leadership is knowing when to tell their teams not to over-engineer a solution. In early development, restraint is just as important as rigor. Good leaders protect their teams from doing work that feels safe and productive today, but actually creates significant hidden risks for tomorrow. So, what's the core takeaway here? In early discovery, the goal of analytics is not certainty. It's what I call useful uncertainty. An uncertainty that is clearly understood, clearly communicated, and intentionally carried forward as a known variable. It's about knowing what you don't know and having a plan to learn it at the right time. In the next video, we'll build on this idea. I'll talk about what the FDA typically expects from your analytics before you submit an IND. And I'll cover some of the common misunderstandings that many teams have when they reach that critical stage of development. Thanks so much for watching. I'll catch you guys in the next one. If you found this helpful, please share and subscribe.